We are continuing with analytical geometry, mathematics paper 2. So we have looked in the previous lesson, we have looked into the distance, we have looked into the midpoint, we have looked into the equation of a straight line. So those are the ones that we looked at. Then today I want us to look at the inclination of a line. So the inclination of a line, as I said in the introductory, that it is the slope of that particular line. So this line with x-axis or even with y-axis, it always makes an angle when they intersect. So in this case, we are going to take a look at the angle that is formed when line AB intersects with the x-axis. So then, how do we go about calculating for that angle that is formed when line AB intersects with the x-axis? So first and foremost, we have to calculate for the gradient of that line. So then to calculate the gradient of the line, we use small letter m of line AB. Instead of when we say changing y over changing x, in most cases we sometimes use y2 minus y1 over x2 minus x1. So we can, to be specific, we can also say yb minus ya over xb minus xa in this case because it's ab. So if it was pq, then it means it will be yq minus yp over xq minus xp, or whichever the variables that they've given you. So in this case, it's AB, then that's why we are saying YB minus YA over XB minus XA. So in that one, what are we having? What is the value of Y at B? It's negative 3. It is negative 3. Then we are having our negative 3 there. And what is the value of Y at A? It's negative 1. And then we go again. Now, what is the value of x at B? It's negative 2. And what is the value of x at A? Is positive 2, which is minus 2. So this is negative 4 over negative 4. Because negative 3 minus 1 is negative 4. And negative 2 minus 2 is negative 4. And of which the answer there happened to be 1. So then, that is what we are having. So if we have it like that, that is the gradient. So then, the angle of inclination, which is angle theta there, how do we go about calculating for it? We say the tan of that angle, which is angle theta, is equal to the gradient of the line. In this case, it's the gradient of line AB. So then, we don't know the angle, but we know the gradient. So it's theta. We say therefore theta. It's equal to 1. So this is what we do in a calculator. We have the calculator and we must make sure that it's in the degree measure. In most calculators it's written D. So look for those small letters there. There's a degree, there's a radian, and the gradient measures. So let there be no R, let there be no G, but D for degree measure. Then what you do is you press either shift or inverse, or other calculators they have written second, which is second function. So you press that button, and then now you come to the trig function. Then you look where it's written 10, you write your 10, and then you press the value of the gradient. In this case, it happened to be 1, and then you say it's equals to. So here it has given us that angle theta it's equals to 45 degrees. So it means the inclination there is equals to 45 degrees. So that is what we are having. Then that is how we calculate the angle of inclination. Let us take a look at another example. Let's say we have another line that goes like that. Let's say this is P, this is Q, and then P, let's say we have negative 5 and 3, and then Q we have maybe 7 and 7 and negative 4. Or maybe 7 and negative 5. Let's make it negative 5. 7 and negative 5. And then again they say to you, determine the gradient, the angle of inclination for that line. So if they say determine the angle of inclination of line PQ. Because we don't know the gradient yet, then it means we must first find the gradient. So what are we going to do? We will just say the gradient of PQ is equals to, then we have to say change in y, which is y2 minus y1 over x2 minus xy. And then now we can make P to be the first point and Q to be the second point. So what is y at P? Is negative 5. So we have negative 5 minus, what is y at P? It's 3. So we say minus 3. And then now we come to what is x at Q? It's 7 minus. And what is x at P? Is negative 5. So we are having negative 5. Then what are we going to have? We will have negative 8 over, then this one is positive. So it is the same as 7 plus 5, because it's negative times negative, which is positive. So then it's 7 plus 5. So then in that case, happen to be 12. And then if it's 12, then when we simplify this, and then we leave it in a standard fraction, then we will have, because the 8 and the 12, their highest common factor is 4. So 4 into 8 is 2, and then into 12 is 3. So the gradient there, it's negative 2 over 3. So if we're having negative 2 over 3, and then now we need to find the angle. So the angle that we must find is that angle there. So let's say it was given as alpha, and then now we need to find that angle alpha. So what are we going to do? We say the tan of alpha, it's equals to the gradient of PQ in this case. The gradient of PQ. So if we're having the gradient of PQ, then now, what is the gradient of PQ? The tan of alpha, it's equals to, in this case, happen to be negative 2 over 3. So then, we say the ref angle of that alpha is, or reference angle of that alpha. Then you go to your calculator. Now we say the shift, and then we say 10. And then you can open up the brackets, and then now you have your negative 2 over 3. You close the bracket, equals 2. So it gives you the negative 33,69. So you can write it as 33,69, and then now we say therefore the alpha is given by 180 degrees minus 33,69. So then that one, what will it give us? So you say 180 minus 33,69, which is equals to 146,31. 146,31 degrees. So that angle alpha here is given, like it is equals to 146,31 6.31 degrees. So that is how we calculate the inclination of an angle. So in the exam, this question may come in different ways. It may come and then instead of them asking for this angle, they may ask for that angle. So what you do is you calculate it using the same method, and then after getting this angle, then because again this is the straight line, so the angle of a straight line we know that it's 180 degrees, so it's 180 minus that. Or when you calculate and they want this angle, you know that that first angle that you get, but it will be negative, then instead of putting the negative, then you will put it as a positive. Or you say 180 minus this angle, and it will give you the 33.69. So that it's up. Or maybe they're asking for that angle, or they're asking for that angle. So you just use the properties of the geometry of straight line and so many other things that like can be used. So that is how that one is done. So I want us to take a look at the example of how a grade 12 paper comes like, or how it's set. So now we are going to take a look at an example of how these questions may come in the final paper, and of which, as a matriculate, on a normal year, you write 3 examinations, that which will amount to your final mark that you get. Those 3 examinations is the June or the half-year examination, and then we also have the preliminary examination, which is written around August, September, and the final examination, which is written around October, November. So then one of the papers, or one of the questions that was once asked in the final exam was this one. That was question 3. It says in the diagram, A, which is -7 and 2, B, which is, it's not given, and then C, it's 6 and 3, D is also not given, and then they are saying are vertices of a rectangle, A, B, C, D. And then they go on, they say the equation of AD is given by y is equals to 2x plus 16. Line AB cuts the x-axis at G. The x-intercept of line BC is given by F, which is P and 0, and the angle of inclination of BC with the positive x-axis is A, and then the diagonals of the rectangle intersect at M. So that is what you see there on the paper. Then what is happening here is there is our Cartesian plane, and then we have our rectangle, which is given in that way. They always say these things are not drawn into scale, so don't look into this shabby shape. It's a freehand. Then what matters most is you are having this in the paper that is displayed there, and then that is the rectangle that we are having, and then this rectangle, that is where we have A, which is -7 and 2, -7 and 2. We have B, which is not given. We have C, which is 6 and 3. We also have D, which is not given. So this is the Y, this is the X. That is what is happening. So in the intersection there, that is where we have F, which is P and 0. And then we also have that angle of inclination, which is alpha. It's alpha. And then we have M, where the diagonals intersect. So M, it's where the diagonals are intersecting. And then we have G, where AB intersect with y-axis. That is the origin with our O. So then, according to those questions that you are having in that paper that is displayed, they say calculate the coordinates of M. And they did not say specifically as to what is that M. But if, like, you know the properties of the polygons, and here they told you specifically to say it is the rectangle. So if you know the properties of a rectangle, you will know that the diagonals always they bisect each other. So when they bisect each other, it means that they intersect at their midpoint. So it's the midpoint of BD and also the midpoint of AC. So even though they did not say the midpoint, but knowing that the properties of the rectangle, whereby the diagonals, they always bisect each other, then now it means that is the midpoint of AC. So then you have to say here the midpoint of AC, which is XA plus XC over 2, and then YA plus YC over 2, whereby now we start substituting. What is X at A? X at A, it's -7. And what is X at C? X at C, it was 6 over 2. And then we go for now for the Y. And then for the Y, what is Y at A? It is 2. And what is Y at C? It is 3. And then now, for substituting into the correct formula, you always get a mark. And then we come to this step, whereby now -7 plus 6, it is -1 over 2. And then this one, 2 plus 3, it is 5 over 2. So those are the coordinates of M by using the properties of a rectangle, whereby we have it as the midpoint of that AC there. And then the second question, they said write down the gradient of BC in terms of P. So they're saying write down the gradient of BC. So here it's the BC, and then it's starting from B to C. But alongside or along the way we have F. So that F there is the one that is given, which is the coordinates of the x-intercept of that line BC. And then A, like B, F, C, it's what we call collinear. And then in the collinear, the gradient of collinear are the same or equal, because it's the same line but divided into segments. So in this case, we are having BC, but along the way, there's that F there. So it means that in this case, they want us to find the gradients of BC, which is the same as the gradient of, changing Y over changing X. So in that changing Y over changing X, what are we going to have? We are going to have those one, like we'll take this to be our second point on F, and we'll take C to be our first point. So what is Y at F is 0 minus, what is Y at C? It is 3 over, and then now what is X at F? It's P, and then what is X at C? It is 6. Then what are we going to have now? We are going to have -3 over P minus 6. So that is the gradient that they want. They said write down that gradient in the form of P. So it means they said you leave it like that. Then you don't even have to worry about what is the value of P. But you just leave it in that way. And then now they say, hence calculate the value of P. So that is the other question. Now they said, find the gradient of BC in the form of P. And then now they're saying, hence find the gradient, the values of P. So if they say find the values of P, what are we given in the above information there? We are given that the equation of this line of AD, the equation of AD is given as y is equals to 2x plus 16. Y is equals to 2x plus 16. That is the equation of AD. So that one, again, it needs you to know the properties of the rectangle. What do we know? We know that the opposite sides of a rectangle are parallel. So if they are parallel, again, you should remember that the equation, the gradients of parallel lines are equal. So meaning that the gradient of this line and the gradient of that line are equal. And what is the gradient of AD? We find the gradient of AD from that equation, because this equation is given as y is equals to 2x plus 16. And what's happening is y is equals to mx plus c. And then m is the gradient. So in this case, the gradient of AD is equals to 2. So you can start by showing that you know that the gradient of AD is equals to 2. And then now you say the gradient of AD is equals to the gradient of BC. Why? Because AD is parallel to BC. This shows that you know the properties of that rectangle there, and then of the rectangle. Then now, if you know that, you will now say, therefore, that gradient is given by 2, it's equals to negative 3 over P minus 6. So to simplify your life is to, cross multiply, which you make this over 1. So you will say negative 3 times 1 and 2 times that. So 2 times P is 2P. And 2 times negative 6 is negative 12. 1 times negative 3, it's negative 3. So that is what we're having. And then from there, what do you do? Then you transpose the 12 to the right hand side. So we're having 2p is equals to, then negative 3 plus 12. You will get that is positive 9. Then dividing by 2. So p is equals to 9 over 2. So that is what we're having. That is the value of P. That is how the value of P is calculated. And then now, the second question, there's like 3.4. They say calculate the length of DB. 3.4, they're saying calculate the length of DB. Calculate the length of DB. All right, so when they say calculate the length of DB, we are coming back, we are looking here. Do we know the coordinates of B? In this case, we don't know. And then, do we know the coordinates of D? In this case, we don't know. So then, but what else do we know as the properties of the rectangle? Is that the diagonals of a rectangle are equal. So what are we having? This diagonal, at least we know everything about it, the diagonal AC. So if we know everything about diagonal AC, if we can calculate that, at least it will give us what we want. So what we can do is to say the AC, or maybe we can just start by saying AC is equals to DB or BD. When we say DB, we just say diagonals of rectangle are equal. So then we have what we want. So therefore we say the AC, because that one at least we know everything about it, we use that formula, and then we have x2 minus x1 squared, y2 minus y1 squared, and then after that, what do we have? We have the 6 minus negative 7 squared, and then plus we have 3 minus 2 squared. And then now, what are we going to have? This is going to be positive, where we are going to have 6 plus 7, and 6 plus 7 is equals to 13. And then 13 squared, it's equals to 169. So 3 minus 1 is 2, so this is 1. So we are having the square root of 170 units, because we are not given anything. Units. So we say therefore the distance BD is the square root of 170 units. 170. Yeah, so we leave it like that because this is the side, and then it can't be simplified any further. So then that is how this one is done. And then now the last question on what we have done so far is to say to us, we have to calculate the size of alpha. There is our alpha. So then to calculate that size of alpha, then again, where is that? That one we have calculated that gradient. So we know that the gradient of BC is equal to 2, because the gradient of BC and the gradient of AD are equal, and the gradient of AD is 2. So then that is what we are having. So we say the tan of alpha is equal to the gradient of BC, where the tan of alpha is equal to 2. And then now we say therefore alpha is, and then we go to our calculator, we go to second function or inverse, we say the tangent of 2 equals 2, and then the answer is 63,43. 63,43 degrees. So this is how this question is just, or how you can deal with it, because we're not given much here, but we are given there. So as we are given there, then now that is how we find that one, because we are using this gradient, which is the same as that gradient, and then now using it, then we got our alpha, or our angle of inclination, which happened to be 63,43 degrees. So then that is how those are dealt with. So sometimes you find that as a rectangle is given like that, and then they did not give you, okay, maybe before we go there, let's just finish up one question. They say now, calculate the size of OGB. OGB. So in short, they want us to calculate the size of this angle there. The size of OGB, which is the size of that angle there. So if they want us to calculate the size of this angle, again, we don't know much about this line, and then we also, like, okay, this line, because of what we have and what we have done, we know a lot about it. What else do we know when we use the properties of a rectangle? Is that this line, the line AB and the line BC, are perpendicular to each other. So if they are perpendicular to each other, it means that when we calculate the gradient, like when we multiply the gradient of BC and the gradient of AC will always give us a -1. The gradient of BC and the gradient of AC will always give us the -1. So if that is what we are now having, what we can do is to say, all right, we know this, the gradient here, and then it means the gradient. Okay, what we can say is to say the gradient of AB times the gradient of BC will give us a -1. So if it gives us a -1, then what else do we have? What we have is to say, now, the gradient, because we know the gradient of AB, or of BC, the gradient of AB times 2, it's equal to -1. So we divide by 2. So the gradient of AB, it's equal to -1/2. So when we know that gradient, it will give us the angle there. So if it gives us this angle, then we are looking at this triangle. This triangle. So this angle is the exterior angle of that little triangle there. So what is it that we know? We know that this angle here is 90 degrees. And then we don't know that angle, and we don't know this angle. And then, but for us, using now again, these are the properties of the polygon, so the properties of a triangle. So we know that the exterior angle of a triangle, in this case, that is the exterior angle of this triangle, it's equal to that angle and this angle here. Like, we add like this angle plus that angle. So what are we going to do when we know that now the gradient, because that one will give us the inclination there, or that angle. This inclination will give us that angle. So we say now the tan of that angle is given by this gradient, which is the gradient of AB. So therefore theta is equals to. So now if that is that, so we say now the shift, the 10, and then we are having -1/2, then it's equals to, so it gives us that -126.57. So what are we going to do? We say 180 minus 26.57, which it gives us 180 minus 26.57, that's equals to. So it is 153.43. Oh, that this 126, it is for here, for that angle there. This angle here, it's 26.57 degrees. 26.57 degrees. Whereby it is the angle inside here, and then here is 90 degrees. So therefore, we will say now, after getting that, we will say, therefore, that angle, that I said it's OGB, is 26.57 plus 90 degrees. And then here you will write exterior angle of a triangle. So 26 plus 90, which is 116 degrees. So 90 plus 26.57 116.57 degrees. So that is how that angle is calculated. So what skill do you need for you to be able to do that? Let us retrace the steps. So what is happening is we know that the relationship between BC and AB, they are perpendicular to each other. And then we know the gradient of this line because of the gradient of that line, because these lines are parallel to each other. So if those lines are parallel to each other, then we use the gradient of this line to find the gradient of that line because they are perpendicular to each other. Then, now, when we use that, we now know that the gradient here, because the gradient here is 2, so the gradient there is negative 2. So when we use that gradient of not negative 2, negative 1 over 2. So when we use that gradient of negative 1 over 2, we find that angle of negative 26.57. But we say 180 minus that, which is that, and then that one will give us that angle there, because when we add this angle, they give us 180. So it's 26.57 degrees. So with the 90 degrees that we know from there, and then we can add them, because they are saying the exterior angle of a triangle is equals to the sum of the interior opposite angles. So then we say 26.57 plus the 90 degrees, and then we get our 116.57 degrees. Thank you very much. We will continue next time.